Hey, welcome back. Okay, so last episode I told you guys that we would be starting on multi-threading, and that's still what we're going to do. Now there's one thing that I want to make clear here. I am not prepared for these episodes. So if we get to the more advanced topics like multi-threading, like the rendering passes that will be correctly doing things instead of this temporary shit, even though this will probably stay for a long time, even though it's ugly. Everything is unprepared, and I did not create this beforehand as well. So it might be that I do some time lapses in between. It might be that I stop talking for a while. It might be that we get some cuts, because we're getting to the more advanced topics like multi-threading. Now, for this multi-threading system, I know that I want some manager for it, so I'm going to make a thread manager. And this thread manager actually is going to be a singleton, a mono behavior. So we need to include the Unity engine. And we are going to remove this namespace. Because we will have a couple of different types of like threads. And well, they can be idle, they can be running, they can be updating, and all that kind of stuff. But there's always one like asynchronous main thread that is actually also responsible for starting and like idling and stopping other threads. And that thread is like one thread that will keep running like on a fast amount of time. So let's first of all maybe not even make this a singleton, because we can do everything as statics here. So to get started, we need some sort of way to determine what kind of like threads we want to be able to run. So we need to be able to specify those in the Unity editor, I guess. So let's just make a string array and call this threads, thread identifiers. Now in awake, we want to populate some dictionary here, which is going to be a private static dictionary. It's going to be of type string, and it's going to be a thread as a secondary, like as the value. Dictionary this. And of course we need to use. And this is going to be like threads is new, blah, blah, blah. And this will include the system that threading. Yes. So this is going to be our main thread handler. But there's going to be one other thread that is not going to be in the thread identifiers, which is going to be like one of the base threads that you can invoke to without giving it an identifier. And that one is the main loop that will actually sleep and create sub-threads. Because the thread handling will also be done on a different thread, so it will not perform impact on the main thread as well, if that makes sense. So there will be one private static thread, and this is the sub-thread. And this sub-thread will be spawned in here, but only if it's not actually running. So if sub-thread, and this whole thread manager, mono behavior instance, will be deleted if it's just awakened, so to say. If sub-thread is null, or sub-thread dot thread state equals yeah. What is a good way to check if a thread is dead or not? Is alive? I mean, it sounds like it. So, or the thread is not alive, then subthread is new thread start, and now we need a private static void execute subthread. And this is one of the base things that we need to do. So now we're going to say, it's not thread state, new thread start. And now we'll do subthread dot start. Because now we got one thread that's running here. Now it's not going to do something. So, well, true. And we do need a on destroy here. But that means that we do not that we should not destroy it here. But now we can just say subthread dot this to abort. Let's just call abort. And then subthread equals null. So we clean it up a bit. Now, while true, we do a thread.sleep. Let's say 10. So we're running this 100 times a second, because this is a milliseconds now, because this is not rendering on the Unity thingy anymore. So this is 100 times a second, which should be good for a sub-thread checker. We can also just sleep 1 times, which will execute then 1000 times a second if it can, which is really, really fast. And now we also have to do something with these threads. Now we're just going to initialize like this dictionary. So for int I equals 0, I is less than thread identifiers, identifiers I++. And of course this is thread identifiers the length. And now if this dictionary like does not contain anything, and let's also clear this dictionary, threads.clear. But before we do this, we are going to do a for each key value pair, because we have to manage this ourselves. Or we could just do for each thread t in threads.values. If t is not equal to null, and then t.is running, is alive? I don't know, like, I think the is alive is the way to go, but, and then we do t.abort, just like this. So we're sure that we're canceling the thread, because otherwise it might be running in the background if we're quitting Unity, and we don't want that to happen. Now we're going to add these things. So we do threads.add. Now we just need a key. So thread identifiers I, comma, null. Because we're not going to start the thread yet, because they are just idle now. They are nothing. So yeah. Now, if we are here, we need to do some things, of course. But first, we need a way to actually like call this thread manager dot invoke to or something, like some way to invoke something to this specific thread. So for this, we need another dictionary, and that's going to be a private static dictionary. It's going to be a string as well, but now a list of some sort of interface that we can invoke where a function is getting executed. Or even maybe we can just pass in a callback. But the problem with just a callback is that we're restricted to one callback. And if we do this with like a class then, or an interface, then we can easily extend on it. So let's go with an interface. So we do iThreaded. That sounds like a good interface. So public interface iThreaded. It's going to be in the generation.interfaces class. And this function will have like a void execute. And we probably will need to handle some sort of thread cancellation token and that kind of stuff. So a CRT. But we'll do that later on. So this will have a list of this iThreaded interface, which we will need to add a using. And this is going to be like invocations is new. So because in here we can store something for the invocations. And again, it might be that we are going to change some things because I'm doing this live and I might make mistakes here because these are getting like a bit more advanced topics. Now, how do we register something to this invocations list? Well, we need to be able to have a function for that, right? So let's make a public static void invoke. Invoke. And now we do a string with our key. And I thread it with our thread. Method. We call it method. Now for this invocations, we will always need to initialize this as well. So this needs to be initialized at the same time as we initialize these things because, well, these things match. But this is just to know which thread to link to, and this is just to know what to like invoke there. So this also means that we can make a class for this because this is double now, and I actually don't want this to be double. So let's make a class for this. So it stores a thread and an action. So this will be like a thread object, like a thread invoke object. Thread, I don't know a name for this. We will start off with a thread invoker. Thread invoker? Yeah, let's call it thread invoker for now, because why not? So it's going to be a public class. This will be in a generation namespace. And this will have a public thread. So now we get the using. This is going to be thread and a public list of iThreaded invocations. And now let's remove all the other usings that we're not using. Now if we make this, we do a public thread invoker. But we do not want to initialize it with a thread, do we? No, we don't. But it's just that invocations should be a new list, like, which is empty. So this is it. So now if we go back to our thread manager, we should actually use this. And now we can get rid of this. And now if we initialize this here, it's of course not thread here anymore. It's thread invoker t in these values, which I need to have a using again. And now we need to do not t, but t.thread and t.thread and t.thread.abort. And we can make an abort method ourselves. That might be a bit better, but okay, let's do this here as well. Because now it's actually initialized correctly, and now we can still use this one singular thing, because now we can say if threads.contains key, underscore key. Then we're just going to add threads.add threads underscore key dot invocations dot add underscore method. So now this one is going to add it to a list of where we need to invoke it to. Now this method should like have like a thing that knows that it should be invoked or whatever. So let's say a public bool should get executed. We'll get a better name probably as well. Return invocations dot question mark dot count. So this question mark is going to be like a null check as well. Oh, then it can return a, okay. So return invocations is, no, we'll just do dot count because we initialize this thing to be like this correct value and then is greater than 0. And now probably I could have done this. I just forget my greater than 0. So now it's a null check as well. So this question mark is checking the invocations is null. If it's not null, then it checks the count. Otherwise it returns false. Either way. Public bool is alive. Get return thread question mark dot is alive. Now this is a null check now. Well, it should have been, but now it's, why is it not? Because it's saying a bool question mark again. Okay, well, okay, yeah. This is always that kind of fun, but okay, then we do it differently. Return thread equals null. No, thread is not equals to null. And then thread dot is alive. We'll just do it with it. We can do it in a one-liner, but I think we're making it ourselves harder then. Return thread dot is alive, else return false. Simple as that. Okay, needed this up a bit. And now this is alive can also be used in order to check if we should actually dispose it here. So we don't have to do this, but we do t dot is alive. And now we can abort it here as well. Because this is important. Because if we execute, well, in here we need to check if we need to execute something on that thread there. So we get a for each here, key value pair, with this string, but we really don't care about the string, do we? So we do a for each thread invoker in threads.values. If invoker dot should get executed. So if we should do something, if invoker that is alive, and if we are not alive, then we should actually make sure that this one is getting alive. So invoker dot spawn. Let's make a spawn method. And this one, the spawn method, will actually get a system.action func. I don't need system according to this thing. This will be a public because I don't care. It might just be a public. And in here we do thread equals new thread starts with our function. And then if our function is getting executed, or well, if we just define this, we just say thread.start. And now we actually spawn our thread in here with a specific function But what function should it be? Because this function is going to be different per like type, probably. Or no, that's not true, because it will just invoke like its internal values on that thread. So now we can just do private static void execute threaded action. I don't know if this is the correct naming, but this is it what this should do. Because this now is just activating that subthread if it is not active, because this spawn will set this and it will start it and it will spawn it and it will be happy, so to say. And if it's happy, it will the next time not say that it is, well, then it is alive and it is getting processed already. So yeah, this check will just be happy. Now this should get executed, will return the value in here, of course. And this list of invocations, this might be a bit of a problem, because this is a dictionary and this is not a concurrent dictionary, which means it's not thread safe. So let us change this to be a concurrent dictionary. And this is just a system of collections thing, but now it is getting thread safe. The only thing that the only problem that we get right now is that we don't have a add, but we only have a try add method. I think, yeah, try add. And if it fails, for now we just debug the log error here. Failed to add basic identifier. It should never get here. I mean, right now we're registering it to it, and it's the only place where we like get this. But because we are accessing this thread invoker from different threads, it might be that this one is getting in a log, or or is it just because this should not be a list? I'm a bit wrong here. This can just be a normal dictionary, because this is just access, and access is not a problem. So let's Ctrl-C this a bit. And well, I think it's important that you guys hear these issues as well, because this is just a live talking about how we go about making a voxel game. But in here, this should not be a list. This should be a concurrent queue. And now this is very interesting, because now we can also just say that set this to a new concurrent queue there. Then we don't need this set up here, and we could have done this with the list as well. So I'm just a bit stupid. And now in here we get a try add method. Enqueue. Yes, and the reason that I wanted to do it this way is because enqueue is safe, but dequeue might be failing. But dequeue can be done a frame later as well, which is not a problem, because that is why we work with multi-threading. So now the enqueuing is ensured, but the dequeuing is not ensured. But that doesn't matter, because it's not getting dequeued, it's not getting removed from that object set, and thus the next time we loop over it, it's fine. The only problem that we have right now is that this thing needs to know which thread invoker object it has. So in here we actually need like this. So that means this function should return like something. But in order to do that with that thread spawn info, we just need to make this an object. And we are just going to be sure that this is going to be this. So we can do hop as an invoker. And now in here, this is going to be a action of object func. And now in this thread start, we do a parameterized thread start with our func. And we start this with our object data set, which is this. So we can call start with this. And now we call this with this object. Now, we're setting this thread invoker here. This is, of course, a little mistake again. We'll just call this one invoker without the underscore, because then we're safe. So now we should always use invoker without, because then we got a correct type. Because this is going to be a while. Because this is going to be while invoker dot should get executed. Because this should get executed is actually trying to get the count, and thus as long as there's items in this queue, we should execute. Right? So now we can actually try to dequeue data from this. So if invoker.try or .invocations.try dequeue, and we try to dequeue without ithreaded result, we can call result.execute. And now we're calling the main results execute function, which can be anything. But this is now executed on a different thread. And if it's back here, then we're back and finished. So we can call like a finish, or we can make like some system that's calling back to the main thread or the thread that it is coming from. We can do all sorts of things with this. So we're spawning now from this subthread, which is updated 100 times a second. Then we're trying to start this one with parameterized data until it is actually no longer required to be executed. We can actually do a thread.sleep of 1 here, because then we have time that it will not just be trying too many times, and we can actually make this one at 10 as well if we want, but let's just keep it like this. And if it should not get executed anymore, then we can still keep this one alive for a while if we want to, but then we need to make an idle system, and yes, we will do this in here later on, but for now this is fine. Otherwise this video will get too long again, because I want to keep the videos under 30 minutes, because otherwise it's too long, even though it's a lot of coding involved into these systems. So right now, I think we're pretty much done. We just need to make sure that we only use one thread manager, of course. So let's go to our scene. And we had an error. Let's see if it's an actual error. It's not an actual error. Okay, so we make this and we generate our new game object. That's this. And we call this one a thread manager. And we assign our thread manager to here. Now we have these thread identifiers. Let's create one for now. And let's call this one rendering. Because we're going to use this rendering for rendering later on. Now if I press play, of course, it is doing something, if I'm not getting errors, but we're not rendering on the rendering thread yet. And I'm getting an error. And why are we getting an error? Let's check it out. So invoker.should get executed. Yeah, what if invoker equals null? Because, well, it is not created yet. That can be because this execute subthread is created here, we start it, and then we're doing this. So let's make sure that that does not happen by actually changing the order of which we do this. And it still does not mean that it is not there, because we still create this one with a null, which is not correct. And that was actually why I was saying that. So let's create this new thread invoker here. It should never be null now anymore. So yeah, it was just that at the beginning it should have been null, and that was fine. But now since we updated that to be our own class, it cannot be null, or it should never be null, because we are expecting one object here in the rendering thread sequence. Now, woo, we got everything up and running. You just don't see it. So how can we see if it's actually running now? Well, you can just go here and add a breakpoint here if you want to, and attach it. And you will see that we will get in here, as you can see. And we will get in here a lot of times, because it is calling it fast. And thus, this will be executed, but should get executed as false. And we're not calling this invoke method yet. And that's going to be our step we're going to do right now. But, oh no, that's not going to be the step right now, but that's going to be the step for the next episode. Because now we also need a way to call back to our main thread. And I don't want to call this one, but let's make another function. That's going to be a public static void invoke main. And it's also going to be an ithreaded underscore method. But this one is just going to be in here, because, well, yeah, that's fine. So this is going to be a special case. This is going to be a concurrent queue as well, because we still need to, like, we're going to add data in there from a different thread, and we're going to read it from the main thread in Unity. So it needs to be concurrent queue, and it's going to be of type ithreaded, and it's going to be like main thread invocations. Invocations is new concurrent queue. Alrighty. So this main thread invocations will be an enqueue of this method, and that's it for invoke main. It's just that we need a void update here now as well. So let's make a void update. And now we can do some configurations. Let's do a public int max main thread invocation. invocations, and let's set this one to, for example, 6. We could also do an MS, but then we need to calculate it again, and that's more performant. And let's just keep it on a number now, and then we'll see how it goes. Because what we do right now is check the amount of items in here. So we go int amount equals this.count. And now we do if the amount is greater than our max invocations, max main thread invocations, then amount equals our max main thread invocations. Then we do the for int I equals 0, I is less than our amount, I++. And we call this not amount anymore, but main invocation count, like this. And well, now we're just going to try to dequeue these things. So we go to our main thread invocations. So if main thread invocations.try dequeue out I threaded underscore results, then we go underscore results.execute. But now this execute is done in the main thread. And yes, if this fails, then we run less operations. That's true. We can just do I minus if that happens, but I think I will just let it go like this. And probably the 6 will be too low or too high. We'll see how that goes. But now we can actually call this invoke main and invoke subthread. Let's call this invoke sub. These two methods in order to execute everything that we need. So we can call to the main thread and we can call to the subthread. And the next episode, we're actually going to implement the calling of the main thread and the calling of the subthread in our chunk renderer class. So that if we call, this render, it will actually set itself up to render on a different thread. But then if it gets back and it's done, and this call is done, from here, we will call back to the main thread in order to spawn this data in. Because this can only be done on the main thread because it's Unity related stuff. So that's going to be the next episode. So I hope you enjoyed, and I'll see you in the next one. Goodbye, and have a nice day.